Okay, now let's see here. This is virtual platform for measurement of self-inductance by Maxwell, which I will repeat. On right hand side, you can see this is your circuit diagram with all parameters existed in four arms. In one arm, you have C1 and R1 parallel connected to each other. R3, R2, and LX. You have to set different values for C1, R1, R3, R2, but LX is fixed here. The LX is 0.045. Now here I will switch off the battery. You can see you can select two different types of coil. One is air core and the second one is iron core. So let us select air core and we'll do one reading. Now on the left hand side you can see the procedure where there are 6 points. So you have to read each end point carefully and according to set all the parameters. Below on this lower side you can see there are certain controls. These are control for changing or for selecting different value of R1, R2, R3 and C1. This control starts from 1 ohms, it is minimum value, goes up to 11.1 mega ohms. So you cannot go beyond 11.1 and you cannot go below 1 ohm value. So according to the formula for L, we have to choose different parameters. Then here you can see on left hand side, there is set inductor value, measure inductor value, and 4 points are mentioned like the current voltmeter reading, inductor value in H, that is Henry, resistance value in ohms, and quality factor. And then there is a simulate button. You have to simulate your Maxwell's bridge after setting R1, R2, R3 and C. So let me start with one reading. Now you have to take 10 reading for this Maxwell's bridge. So always remember your R1 value and your R2 and R3, they have specific units. So always keep R1 and R2 in mega ohms and R3 in ohms. So now for the second reading, I will select R1 as 9 mega ohms. So this is my R1. Use the control pin, control button, and just with slider go ahead and adjust this is to 9. So now with this control, when you can see up and down arrow is there, so that will not work properly. You have to choose R1 from the slider. So that I'm changing. Okay, now my R1 is 9.05354 mega ohms. So please all of you note it down in first column of R1, 9.05 mega ohms. Then you have R2. R2 also you have to keep R2 in mega ohms. So now this time I will choose R2 as 8.5. So let us change R2 to 8.5. Now you can see it is 8.02. So with this slider, I will change. Yeah, this is now. Yeah, now my R2 is 8.539 mega ohms. Then you have to select R3. Initially R3 was 11 ohm. Now I will select R3 as 10.5. So with this up and down arrow, easily you can change this value for R3. So I'll select 10.5. So here this is 10. Now with this keyboard, I can write 10.5. So I can select 10.5 and R3. Then we have C1. Let us choose C1. So for first reading, C1 was 0.4. Now I will select C1 as 0.45. So with this up and down arrow, you cannot select 0.5. So I will use keyboard and I will write 5. So now C1 is 0.45. So I will repeat in the column R1 9 mega ohms, R2 8.53 mega ohms, R3 10.5 ohms, C1 0.45 nanofarad, and then your LX is fixed, that is 0.045 for air core. Now the battery is not on, it is switched off as the red button is not going. And you can see pointer is at 0. So there is 0 volt in multimeter or your millivoltmeter. Now what you have to do? ये on करना. You have to switch it on. Now this is glowing. It is on. Now whatever parameter I have selected is perfectly alright. How can I say this is correct? Because in this millivoltmeter range on the window, your voltage is 0.01065, which is almost equal to null voltage. So in the observation table, you can write reading for millivolt or reading in the window 0.01065. Now this adjustment part and this right hand side virtual part is done. Now let us come to left hand side with simulate. आपको इस simulate पे click करना है. So the moment I will click on this simulate, now you can see some values. So let us compare. So the current voltmeter reading is same 0.01065, but whatever inductor coil or inductance value in Henry I have selected, that is 0.045, that is observed. And now with this simulator, I am getting 0.040. This is not bad. This is approximately equal to 0.045. Resistance value is 9.904. And of course, quality factor, which should be less than 10, I am getting 1.27. So this is what your observation with virtual platform. Now what you have to do, students? You have to calculate the inductance value with the help of formula, as well as you have to calculate the quality factor with the help of formula. Is this part is clear? Then I will show you the calculation. Is this virtual platform is clear how to perform the experiment? Students? Yeah, I'm waiting for your reply. Is this part is clear?
Yes, ma'am. Yes, ma'am.
Okay, okay. So now I'll go back to formula part. So here you can see in procedure, you have here in theory, see some formulas are mentioned like here Q factor. You can see the expression for Q factor can be written as Q is omega. So ये सब statement में लिखा है, but you have to write in terms of parameters. Okay. So for that, whatever the formula for L. So now one question to you: what is the formula for L? Yes. Who will tell me the formula for L? All of you, please do this calculation. Now, is the screen is visible for this Excel sheet?
Excel sheet is not visible, ma'am.
Okay. Now Excel sheet is visible?
Yes, ma'am.
Okay, now this is your observation table. Now what I want, first you have to select this value. So I have selected R1, 8.99, all the selected value. I cannot go beyond 11, as I said. Then R2, then R3, and these are selected C1. Now for each reading, that is for first reading, we have calculated for 0.4. For second reading, third reading. So for each reading, you have to simulate your Maxwell's bridge. And on the left hand side, as you can see, there is a windows which will give you certain value that you have to write, that is L calculated, and this Lx Henry will remain constant. But for safer side, what you have to do, you have to write formula. So during exam, you have to write formula for L. So as you said, formula for L is what? What is the formula for L? Just now you said, no?
2R3 C1.
One. Formula for L is R2, R3,
C1.
R2, R3 and C1. So all of you please pay attention here. ये आपका formula है R2, R3, C1. Now we know what is your R2 value. Let us take second reading. R2 value is 8.5 is mega ohms. R2 is 8.5 mega ohms. That is 10 raised to 6. Then multiply this 8.5 mega ohms with R3. So R3 is 10.5 ohm. And then multiply this with 0.45. 0.45. It is nanofarad. Nanofarad means into 10 raised to minus 9. Use your calculator. All of you, please use your calculator and calculate this value quickly. Do this calculation and write in the chat box. Yes, take your calculator, do this calculation and write in chat box what is L calculated with these parameters. This is 8.5 mega ohms into 10.5 ohms into 0.45 into 10 raised to minus 9. So my answer is coming as 0.040165. Now I'm going to write this value 0.040165 and I will put it here. I'll just write it down. 0. So my next reading is 0.040163 और हमने select कितना किया था? It was 0.045. So you can say they are approximately same. Is this point is clear? Then there is a Rx calculated. Now this Rx you will get from virtual platform, which was 9.91 for this reading. Okay, thanks Sakshi. And then Q factor was 1.12. Even for Q factor, you can write formula. You can write Q factor and just write formula for Q factor here and do this calculation. So you can make two tables. One Q factor from simulator, virtual platform, another Q factor from calculation. Then here you have millivolt reading, which you will write directly from the virtual platform. It was 0.0113 for next reading. And the last and very important part is calculation of L by C. So all of you pay attention here. You have to calculate L by C. As you calculate it, your L is 0.040163. And you divide this by C. C कितना है आपका? 0.45 into 10 raised to minus 9. Do this calculation, students, quickly for me. All of you do this calculation. Write 0.040163 divided by 0.45 into 10 raised to minus 9. और मुझे बताओ आपका L by C factor कितना आता है? All of you do this calculation and write in chat box quickly. Here I will write 0.040 divided by 0.45. This calculation you have to do, and here you can make one more column and write answer. Write answer here, and whatever answer you'll get after dividing L and L to C, that you have to write. In this way, you have to make this observation table in the exam. During exam, you have to make observation table, and you have to tell me from your side which value you want to take reading. So whatever you will tell me, I will accordingly, I will change the contour. So any questions here? Any questions for this Maxwell's bridge? Okay, सबका आंसर
No,
निकल
ma'am.
आंसर हो गया आपका L by C कितना आया? L by C कितना आ रहा है यहाँ पे लिखेंगे हम लोग. Okay, 0.11. We are saying 0.11. That please all of you can verify this answer. So in this way, this observation table you have to complete. Then again we'll go to a virtual platform. So here you can see in this virtual platform, I was in simulator. यहाँ पे थे हम लोग. Okay, so here again, if you want to take third reading, so please keep your observation table for R1, R2, R3 and C1 ready, and according to your selected value, you can just change this R1, R2, R3 with this control button, simulate and do the work. So I think that's all about this measurement of self-inductance by Maxwell's bridge. Still, if you have any difficulty, you can ask the question. Yes. Students, any doubt, any questions? Students?